All right, guys, welcome to task 4.3. We're talking about counting techniques today. So that seems like a very kind of basic topic, but in probability, it's a little bit more complex way of trying to count up the number of options or probabilities, things of that nature. So that's kind of what our main focus is today. So first thing is what's called the multiplication rule of counting. So again, when we're talking about counting, we're trying to count up the number of options we have in a certain situation. That makes it a lot easier for us to find the probability if you know the total number of possible outcomes in which there are. So the example that I want to use to kind of demonstrate this is, well, how many different types of pizzas can I get if I have all these different options, right? So I have a choice of 3 different sizes, I have a choice of 3 different types of crust, I have a choice of 5 different types of toppings which I can put on it, right? So I could go and try and list out, well, I could get a small thin crust supreme, I could get a small thin crust Hawaiian, I can just try and list out all of those, but that takes a long time, right? So what this allows us to do is say, well, there's 3 sizes, 3 crusts, 5 toppings. I just multiply all of those out, 3 times 3 times 4, sorry, 3 times 3 times 5, I get 45 possible options for pizzas, right? And that's it. It makes it really super easy and fast for us to find our number of options by using that counting rule. All right, so another way that we can get that same result, but typically in a little bit nicer of a way, is with what's called a tree diagram here. So the benefit here is it shows us what each option is, as opposed to, hey, here's just what the total number of options are, right? So I want to flip a coin 3 times, right? So I could say, well, that's 2 times 2 times 2, because there's 2 options, heads or tails for each flip. So that's 8 options total. Great. But what are those options, right? So that's what the tree can help us do. And say, well, my first break apart here is I could get heads or tails, and then heads or tails, and then heads or tails. So I draw that branch after every flip. So now, if I follow one branch from the start to the end, heads, 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 my outcome there was heads, heads, heads. If I go tails, heads, tails, tails, heads, tails, that's that option there. So then on the far right there, I have listed every single one of those options. And that's typically what you're going to do. The main tree is just over to here. But then once we're there, we typically want to list out, hey, what do each of these options mean overall? It just makes it a little bit easier and faster for us to kind of find all of the options which we have. So let's try this out. Okay. So let's say that I am playing 3 tennis matches. Okay. The outcomes of those are either win or loss, right? So we could first draw a tree diagram of all of those options. It'll look very similar to one we just looked at. Okay. Then once you have that, fill out this table here, and then go ahead and come back. All right, so we should get this. Again, we should have 8 possible options there, right? And then we list all of those out. Here's what the rest of those were. And then 2 times 2 times 2, 8, just like we saw. Right? Okay, so the next step up beyond that is going to be a tree diagram with a probability, right? So what we just did was more about, hey, here's what the options are, which is great, but lots of times there's different probabilities of different things happening. So for instance here, there's a 2/3 chance of me getting red, so 1/3 chance of me getting blue. Right? So for me to go red, red, well, that's 2/3 to get red, red, which is 2/3 times 2/3 or 4/9. Right? For me to go red, blue, that's 2/3 times 1/3, which is 2/3 times 1/3 or 2/9. For blue, red, that's 1/3 times 2/3, 2/9. For blue, blue, 1/3 times 1/3, 1/9. Right? So it's the same thing we just did, but now we're going to be multiplying those probabilities as we go through them. And typically we will write that probability kind of on the little branching tree line thing there, whatever that's called, right? And so we can have all, well, it's 2/3 times 2/3, that's red, red. 2/3 times 1/3, that's red, blue, and so forth, right? And what you should find is at the very end, if we were to add up all of these different probabilities, you should get 1, right? Because that's 100% chance. So 4/9 plus 2/9 plus 2/9 plus 1/9 is 9/9. or 1. Okay, so now here's the term factorial. Now you likely have seen this in the past in some of your earlier math courses, but what a factorial means is it is a number and then you multiply it by every number less than whole numbers down to 1. So 4 factorial is 4 times 3 times 2 times 1, right? That's kind of fun, but why would I do that, right? So let's say I would figure out, well, how many ways can people place in a race? So let's say I have 5 people that are in a race. The options of people that could get first place, well, there's 5 of them because there's 5 people who could get first place, so 5. Well, then how many people could get second place? Well, you might think, well, all 5 of them could get second place. That's not true, right? After the first person has gotten first place, they can't then also get second place. So now there's only 4 options for second place. So 5 for first, 4 for second, 3 for third, 2 for fourth, and only 1 option for fifth place. So I could simplify that by just saying, hey, 5 factorial is my number of options for 5 people running in a race. Okay, and that's effectively where this gets used. Because we quite often take this times 1 less times 1 less times 1 less because of those options being removed as they are going down that list. So that leads us into what are called permutations and combinations. And again, if you've taken any kind of minor stat stuff or probability stuff in the past, you've likely seen these in the past. So I'm just going to kind of recapping those. So a permutation is when the order matters, right? So like in a race, first place and second place and third place matters. And like first and third aren't, yeah, they're both top 3, whatever, right? The order there matters in which you finish. Okay. If I do a random draw and say, hey, I'm going to draw five people, and those 5 people all get a $5 gift card. It doesn't matter if I draw you first or I draw you third, you still get the same gift card. So in that case, it doesn't matter, right? So when it does matter, we call that a permutation. When it doesn't matter, we call that a combination. Okay, so for this permutation, we have NPR. Okay, that P is a capital P. The N and the R are typically subscript numbers. So the N is your sample size, and the R is the number of things you care about. So let's say my race of 5, I only care about the first 3 finishers. Okay, so that would be 5, because I have 5 people in the race. Where's my cursor? There it is. 5P3, because I care about only the first 3. So I would say 5 factorial, divide that by 5 minus 3 factorial. So now, why am I doing that? Well, let's take a look at what that does. Oops, wrong slide. There we go. So if I have 5 factorial divided by 5 minus 3 factorial. Well, 5 factorial is equivalent to me saying 5 times 4 times 3 times 2 times 1. Oops, sorry, there you go. Well, 5 minus 3 is 2. 2 factorial is 2 times 1. So mathematically, my 2's cancel and my 1's cancel, so all I do is 5 times 4 times 3. Because if I think about that, in my race, I have 5 options for first place, 4 options for second, 3 options for third. And I don't care about any other combinations there, so then I'm done. 5 times 4 times 3. So what this is doing is it's saying, hey, this n factorial, saying, hey, here's everybody. But then down here, this n minus r factorial, this says, hey, this will take out all the parts past the ones we care about. So after those first 3, they all just cancel out because of this. So that's what that part there is for. So then on a combination, that's the same thing. So you can see the same idea of n factorial over n minus r factorial, but we also don't care about the number of ways but we don't care about the order. So once I've chosen those first 3, well, the third place could be first or second or any, so those three people changing order doesn't matter. So to figure out, well, how many ways could those three people change orders would be, well, 3 times 2 times 1, or 3 factorial. So I also want to divide off that. So hence us seeing this also dividing by r factorial. So that r factorial takes care of things which are those same people, just in a different order. Okay, so that's effectively how those things work. Now, I try and explain what's going on there, but there are buttons for your calculator for doing this, because this can be very, very tedious to do by hand. Typically, it is under the math menu and then the probability option. If you are having a hard time, please ask, and I will try and help show you where those options are at. Okay, oops, change scenes, it's not showing up. There we go. All right, so let's try this out. Okay, so the board of directors at the community hospital has 12 members, three officers, a president, a vice president, and a treasurer. Do we use a permutation or a combination for this? Well, does the order matter, right? So does president versus vice president versus treasurer, are those different roles? Yeah, right. Me being president versus them being vice president is a different outcome to them being president and me being vice president. So the order matters there. So that's a permutation. So the values here is n is 12 because there's 12 members, and our r is 3 because there's 3 people who we care about there. So if we use our permutation rule there, I guess I don't have a slide for that. Let's pull up my calculator. So I would go this one, 12, and then NPR 3. 1,320 different ways which I could choose my president, vice president, and treasurer out of those 12 people, which is a lot. And what you'll find is that these numbers get really, really big, really, really fast. Okay, and then the other option, 3 members of a group of 12 will be selected to go to a convention. How many different groups of 3 are there? So okay, so again here, does the order matter, right? If I'm choosing 3 people, it doesn't matter if I choose you first or if I choose you third, you're still going to the convention, right? So here the order doesn't matter. So this is going to be a combination. And here, once again, 12 and 3 for my N and my R. So when I go and type that in, so 12 combination 3, I get a drastically smaller number, right? Because 220, right? Because once the order doesn't matter anymore, we get way fewer options. So your combinations are typically be very, very much smaller than your permutations, even of the same values there. All right, so with that, sorry, click over here. There we go. So with that, here is our homework for 4.3. We're doing 1 through 2, and then 3 through 27 is just the odds. And then that does finish off chapter 4 for us. So the next thing which we do, which is going to be the review for chapter 4, is going to be 1 through 19 odd. With that, I will talk to you next time.